Shin? Hippo? Not yet. Okay, I wait for Shin. The rest of you have done right. You can look at question 12, which is D2. Okay, let's move on. Next question. Okay, they talk about stationary point. Now, this question they say find the x-coordinate of the stationary point, whereby your question is y equals to 3x multiplied 2x plus 3 to the power of 6. Now, first of all, when I look at this question, I know I'm going to use product rules. Okay, we're going to use product rules. Okay, so first thing I will let my u equals to e3x, v equals to 2x plus 3 to the power 6. So u prime differentiate exponential, I get 3e3x. Okay, v prime I'm getting is using chain rule, so drop down to the power 6 bracket 2x plus 3. Okay, power will reduce, but don't forget your argument 2x plus 3 has to be differentiate again. So what you get is 2. So basically your v prime is you're getting 12 bracket 2x plus 3 to the power of 5. Okay, now we start to differentiate. So dy dx. So cross multiply, we get v u prime, so which is 3e3x bracket 2x plus 3 to the power of 6, okay, plus 12e3x bracket 2x plus 3 to the power of 5. Okay, I'm going to find my stationary point, right? So basically, please write it down, dy dx equals to 0. Okay, so that means when I want to do dy dx, first of all, I need to do factorization. Otherwise, I can't work out the entire whole thing. So common factor for both terms, right? I have 3e3x. 3e3x. Okay, at the same time, I have another factor 2x plus 5. Okay, so I will take out 2x plus 5 to the power of 5. Okay, what is inside? Don't forget, I'm going to split this one. This will be 2x plus 3 power 5 multiplied 2x plus 3. So my 2x plus 3 for another power, I will put inside plus 3. Okay, and then 12 will plus 4 equals to 0. So continue to work it out. 3e3x multiplied 2x plus 3, sorry, not 5, plus 3 to the power of 5. Okay, inside here I get 2x plus 7 equals to 0. So to continue to work it out, I will let my 3e3x equals to 0, 2x plus 3 power 5 equals to 0, and 2x plus 7 equals to 0. So this part, when you work it out, right, you will get, you see, your 3 multiplied with 0 definitely get 0. So 3x equals to ln 0. Basically is rejected because ln 0 is undefined. However, we work on the second argument. When you look at the second one, you will notice your power move to the other side also become a 0. So basically, you just need to solve out 2x plus 3 equals to 0. So my 2x equals to negative 3, x equals to negative 3 over 2. Okay, last bit. So I will have 2x equals to negative 7, x equals to negative 7 over 2. So my solution for this question, you will get x equals to negative 3 over 2, x equals to negative 7 over 2. That's it. So I give you some time to copy it down, then after that we move on. Once you're done, press 1. Not yet, press 2. Thank you. So I'm waiting for Yibo. Okay, let's see what Yibo can do. Okay, good. Okay, we'll move on to B. Okay, a curve have an equation f(x). Okay, exactly have two stationary point. Okay, so sometimes you cannot do part 1, right? You look at part 2. Part 2 will actually give you the hint. Your answer only have two stationary point. They give you second derivative of f double prime x is 4x minus 7, f prime x 0.5, and f prime f3 equals to 3. Both are 0. Now, the next part, highlight the keywords. Use the second derivative test to determine the natures of each stationary point. So basically what you need to do is, from your first derivative, they already tell you f prime 0.5 equals to 0. That means your x equals to 0 is one of your stationary point. Okay, same thing, x equals to 3 is your stationary point. So you have to use 0.5 and 3 sub into second derivative. So first of all, I will do x equals to 0.5. Okay, sub into double prime of 0.5. So my double prime is 4x, so replace my x to become 0.5 minus 7. So from here, I get negative 5. So basically, it's less than 0, right? So I can say that these have a maximum point. Okay, maximum point at x equals to 0.5. Okay, therefore, okay, next one, when my x equals to 3, what happened to my second derivative? So I sub in 3 into 4x minus 7, I get 5. Okay, it's a positive value. So basically, if more than 0, I get a minimum value. So therefore, it gives you a minimum point at x equals to 3. That's it. Okay, if you're done, then you can press 1. Too fast also tell me, I will slow down a little bit for you. Okay, good. We move on. Question 4. Okay, let's look at the next one. Okay, next question. Now, this question is potential, will come out in paper 1, non-calculator paper. It is given y equals to tangent 3x over sine x. Okay, basically, we're going to use, what are the rules we're going to use? Can anyone tell me before I start? For the differentiation, because I'm going to do my differentiation, what kind of rule I'm going to use? Product? No. Hello? No product. What is that? It's a fraction. Use who? What rules we're going to use? Quotient, yes. So we're going to let my numerator become u, my denominator become v. So we will let u equals to tangent 3x. Okay, let v become sine x. So differentiate u prime, I get 3 second square x. Don't forget, you have to differentiate your 3x. Okay, next one. V prime, I will get cos x. Okay, we continue to work on it, dy dx. Okay, so I know my v square is going to be sine square, so you can put sine square x. Okay, bear in mind, sine square x same as sine x square, they will be the same. Okay, I need some space, so we continue to work on the next part. Okay, cross multiply v and u prime, so what we get is 3 sine x second square x minus tangent 3x cos x. Okay, so once we've done this part, what we're going to do is we're going to take substitute x equals to pi over 3 into my dy dx. So dy dx, I will get 3 sine pi over 3 second square pi over 3 minus tangent 3 pi over 3 cos pi over 3 over sine square pi over 3. Okay, they want it in exact value, so we continue to work on it. Okay, when the moment they say want exact value, okay, always bear in mind you have to remember your special angle. Okay, now I will get 3. Okay, my sine will become sec 3 over 2. Second square, okay, second square, that will be 1 over cos pi. Okay, you have 3 here. Second, you have the 3 or not? Yeah, second 3x. 3 times pi over 3. Okay, so second square x, right, is actually cos pi, so it also become 1 reciprocal. Okay, minus, okay, what is the next one is tangent pi is actually 0, so we multiply with cos pi over 3 is actually half. So what about second square pi over 3? You will get sec 3 over 2 and square it. Okay, we continue to work on it. So the question what we get is dy dx will equals to 3 sec 3 over 2 dy by, okay, I multiply in my square, I get 3 over 4. So flip 3 sec 3 over 2 multiplied 4 over 3. So we simplify. Okay, I will get 2 sec 3. Okay. Okay, I give you about 1 minute to copy it down. Then we move on to the next question. You Jun Ngo, may I know which class are you from? Okay, thank you. Okay, guys, done. Please press 1. Not yet, press 2. Right, we look at the next question. Find the approximate change for um, y as increase for pi over 2 to h. So from here we know my delta x is equals to h. So the delta y from part 1 answer I get 2 third 3 multiplied with h. That is the final answer. Okay, next part they ask you rate of change, okay, in y. So basically they are asking you to find your dy over dt. Okay, when your x is pi over 3, give your answer, okay, highlight the keyword simplest third form. And one more thing, in this question they also tell you that increasing rate at the rate of 3 unit per second, that is represent your dx over dt equals to 3. So first of all, I'm going to form my uh, dy dt. So in the question, my dy dt is dy change to dt, split them. Okay, what I'm going to have is I have dx dt, at the same time I have dy dx. So my dy dx from part 1 that I have done is 2 third 3, and then dx dt is 3, so you will get 6 third 3. That's it. Okay, done. Then press 1. Iponan? Ipo not yet. Okay, thank you. Okay, we move on to the next one. Okay, next question. Okay. This question actually involving for integration. If I don't start with part A, maybe you can't do for part B. So I will start a little bit of integration. Okay, what is the question say that? You just bear in mind, later I will explain the rules. The gradient of the normal of the curve given by x over x plus 1. What does it mean? That means in this question, they are saying that gradient of normal, that means your gradient of your reciprocal equals to x over x plus 1. So what about my original gradient? So my original gradient, right, what we're going to do, we're going to flip the fractions upside down and multiply with negative 1. And what do we get? X plus 1 over x. Okay, this is also represent your dy dx. Okay, first sentence I already interpret and try to find out what is my dy dx. Okay, now we look at part A, what they want. Given that curve pass through 1 and 4, now they want you to find the original equation, that is to show this is y equals to 5 minus ln x minus x. Okay, I know some of the classes not yet into integrations. So may I ask, like Oxford, have you done your integration or not yet start? Oxford and Imperial. Not yet. Imperial? You June? Okay. Okay, this is second part of the integration because I want to do B for differentiation. So I will start a little bit, you just bear with me lah. Okay, now for now given they give you dy dx, which is equals to, okay, I'm going to split them x over x plus 1 over x. Okay, because I'm going to find my original equation, what I'm going to do, I'm going to integrate. So when I integrate, I will put dy, bring your dx to the other side, okay, equals to integrate 1 plus 1 over x dx. Okay, I'm going to integrate this part. Okay, okay, now before I start integration, I will tell you the story first. When you have y, okay, we differentiate, you will get dy dx. Correct? When I have dy dx, I want to know the original, what I need to do, I integrate. Okay. So integration also we call reverse differentiation. Okay, let me ask you, if I give you y equals to x, dy dx, what I get? 1, correct? So if I give you dy dx equals to 1, I do the reverse way, integrate. This is integration sign. The pink curly bracket is integration sign. What did I get? I get back x. So for this question, I will get 1 is x. Okay? Now, next one. Okay, you look at if my y equals to ln x. Okay, my dy dx is 1 over x. Correct or not? Right? So, if I integrate my 1 over x, what happened? It's a reverse of differentiation. So, it becomes ln x. So, basically, I will put ln x. Okay? Okay, one more. If I have y equals to any number, maybe negative 5, what do you get for your dy dx? Anyone can answer me. Y equals to negative 5, what do you get? From that negative 5, differentiate, what do you get? Okay, 0. So in other words, my negative 5, isn't it a constant? Any number lah. Constant means any number. Therefore, when I integrate, okay, at the end, I need to put my original equation as plus c, a constant. Hello, Arvin. Arvin is, I think, Cambridge, right? Okay, so we continue. Therefore, come to this question, after we integrate, we get x plus ln x plus c. All good? The existing student, are you all good? If all good, press 1 before I continue. Yunbo and Yipo, I know you haven't learned it before. You will learn after the exam because I want to do the part B. Okay, so I have no choice. I have to teach you part A first a bit. So you bear with me, try to understand before I continue. So Yipo, are you okay? Not yet, I not yet put. Okay, so my sorry, here I have to put back negative, right? Okay, I will put outside. Thank you. So what is the next one? We continue to work out the original equation. So what is the next step is I'm going to sub in my 1 and 4 into my y. Okay, so okay, substitute. Okay, y 1 and 4 into my y. So what did I get here is I will get 1, y equals to 4 equals to negative 1 negative ln x plus c. Okay, your x is ln 1. So basically this entirely will become 0. So my c will equals to 4 plus 1, which is equals to 5. Okay, so next part. Okay, I'm going to erase this one because a lot of you already copied down. Therefore, my equation, okay, is y equals to 5 minus ln x minus x shown. Okay? Done, then press 1. Because this question I go very, very slow. I know some of the classes not yet covered for integration. Okay, we wait for Yipo. Alvin, are you alright? Yipo? Yipo done, then press 1. Arvin, so sorry because I finished part A and explained in a very long, but hold on with me, maybe later you replay the video and watch. Can? Yipo done? Okay, we will move on to B. Okay, my concern is about B. Okay, B, they say find in the form of y equals to mx plus c. So what do they give you is my final answer must be y equals to mx plus c, equation of tangents to the curve whereby x equals to 3. Look, your x is equals to 3 is not equals to previous question is 1. So this one you need to pay attention with it. So first of all, right, for equation of tangent, what I need a point. Okay, they give you the point x equals to 3. So I need to find my y. So what I'm going to do is I'm going to sub into my original equation from part A, 5 minus ln 3 minus 3. So my y equals to 2 minus ln 3. So I got my point of 3. When my x equals to 3, my y is 2 minus ln 3. Okay, first thing done. I got first information. Second information, I need to get my m. Okay, my m is actually my dy dx. Okay, so my original equation is y equals to 5. Wait, y equals to 5 minus ln x minus x. But from my previous working, I get my answer will be my dy dx is actually negative x plus 1 over x. Okay, you look at my solution here. Okay, so I need to find my dy dx value. So the next step, what I'm going to do is I'm going to substitute x equals to 3 into my dy dx. So dy dx will equals to negative 3 plus 1 over 3, which is negative 4 over 3. Okay, second information I got it done, so I can form my equation of tangent now. So in my equation of tangent, what I'm going to do is I'm going to substitute the point 3, 2 minus ln 3 and dy dx equals to negative 4 over 3 into y equals to mx plus c. So from here, what I get is 2 minus ln 3 equals to negative 4 over 3 times 3 plus c. So work it out this part. I get 2 minus ln 3 equals to negative 4 plus c. So my c equals to 2 minus ln 3 plus 4. So c equals to 6 minus ln 3. So therefore, my equations of tangent is y equals to negative 4 over 3x plus 6 minus ln 3. Done, press 1. Ibo and Alvin. No, Alvin, if you've done copy down, then you just press 1. Are you done? Alvin, are you done? Okay, thank you. Okay, move on to the next question. Okay, variable x and y such that y equals to e2 over x plus x cos 2x, whereby x is a radian. Highlight the keywords, huh? That means we're going to use radian to calculate my trigonometry. Use differentiations to find the approximate change in y, okay, whereby your x increase 1 to 1 plus h is very small. So first of all, I can detect my delta x is actually h. Okay, second thing, I need to find my dy dx of these equations. Okay, now first thing first, I'm going to separate them, work out this product rule first. Okay, so x cos 2x, so I will let this x become u, this cos 2x become v first before I start to differentiate. So let u equals to x, let v equals to cos 2x. So u prime equals to 1, v prime, what I get is negative 2 sine 2x. Okay, now I start to dy dx. So from my dy dx, my e x over 2, it will become 1 over 2 e x over 2. Differentiate your x over 2, so become 1 over 2 and bring down. Okay, second thing, I'm going to do a product rule for my trigo. So taking v multiplied with u prime, so I get cos 2x. So I'm going to take x multiplied with negative 2 sine 2x, so I minus 2x sine 2x. Okay, I'm done with this part. Second part, what I'm going to do is I'm going to substitute my x is 1 into my dy dx. So dy dx equals to half e half x plus cos 2 times half minus 2 times half sine 2 times half. Okay, simplified. This is cos 1 and sine 1. Okay, let's start to simplify. So dy dx equals to half e half plus cos 1 minus sine 1. 2 1 1. Oh, sorry, here should be cos 2. Cos 2. I put 1 there. Cos 2 minus 2 sine 2. 2 sine 2 cos 2. Okay, calculator will give you negative 1.41038 something, long decimal. So your delta y approximate change is 3 significant figure. So you will get negative 1.41 3 significant times h. That's it. Thank you. Okay, we move on to the next one. Okay, you look at the next one will be D9. Okay, a curve has equation y equals to 2 plus sine 3x over x plus 1. Okay, the question asks you to show that exact value of dy dx, where the point is pi over 6, can be written in this form. Okay, same thing, when come to this question, we were going to use quotient rule. So letting your numerator become u, denominator become v. So let's start. So we let u equals to 2 plus sine 3x. Okay, v equals to x plus 1. So u prime, I will get 3 cos 3x, v equals to 1, v prime. Okay, now we start to differentiate dy dx. Okay, quotient rule, so cross multiply. Okay, at the same time, my denominator I put x plus 1 squared cross multiply here, I get 3 bracket x plus 1 cos 3x minus 2 plus sine 3x. Actually, I prefer open bracket lah. That means you multiply in your negative inside straight away. Okay, do you need to simplify or anything? I don't think needed because they already give you very clearly your k is a constant over pi over 6 plus 1 squared. So I can immediately just substitute my x. X equals to pi over 6 into my dy dx. So dy dx. Okay, from here, right, my denominator x will become pi over 6 plus 1 and then square it. See, for the top here, I got 3 bracket pi over 6 plus 1. Okay, cos. Here, right, I will get 3 bracket pi over 6. Okay, minus, I expand it out, 2 and minus sine 3 bracket pi over 6. Okay, simplify this, I get cos pi over 2. Simplify this, I get cos pi over 2. So we move on the next part. So my dy dx equals to pi over 6 plus 1 square it. So here I get 3 bracket pi over 6 plus 1. Okay, cos pi over 2 minus 2 sine pi over 2. Okay, special angle again. Take cos pi over 2. Here will become a 0. So entirely this expression will become 0. Okay, how about sine pi over 2? This will become 1. So in other words, right, when we all work on it, what do I have is negative 2, negative 3, negative 1, bracket pi over 6 plus 1 square. So what did I get? Negative 3 over pi over 6 plus 1 square. So isn't it same as what they give me? K over pi over 6 plus 1 square. So therefore, what is the value for your k? K equals to negative 3. Okay, let's move on. Wait, I have another one. KG only now join. KG, I give you some time to copy. KG, you done? Then press 1. Okay, we move on the next part. Okay, the next question, they are asking you to find the equation of normal, okay, where the curve as x equals to 0. So basically, what are the information I need from the question? Okay, first of all, what is my dy dx? Okay, from here I need to get a point. So my point x equals to 0. So I put into my y. So my y value here is 2 plus sine 0 divided by 0 plus 1, which is equals to 2. So first I get my point 0, 2. Okay, second thing, I need to find my dy dx. From previous question, my dy dx is 3 bracket x plus 1 cos 3x minus 2 minus sine 3x over x plus 1 square. Okay, so I will substitute. Okay, x equals 0 into my dy dx. So my dy dx we're getting 3, 0 plus 1 cos 0 minus 2 sine 0 over 1 square. Okay, come to this part, you must know cos 0 is actually 1, sine 0 is equals to 0. So from here I will get 3 minus 2 minus 0 over 1, which is equals to 1. Okay, but I'm one equation of normal. So in other words, the 1 here represents my gradient. So my gradient of perpendicular is -1. Okay, so next step I'm going to substitute. I got two information already, 0 and 2, and my gradient of normal equals -1. Sub into my y equals to mx plus c. So from here, right, you get 2 equals to -1 times 0 plus c. C equals to 2. Therefore, my equation of normal is y equals to -x plus 2. That's it. Mm. Oh, KG, you are here. So she left. Alright, we continue the next one. Okay. Next question, they give you that even that x equals to 2 plus secant theta, y equals to 5 plus tangent square theta. Question asking, express y in terms of x. How are we going to do this type of questions? So first of all, my advice is you try to look back your formula list. What I can spot one of the trigo identity from here. Okay, remember secant square theta equals to 1 plus tangent square theta. So to work out this part, I want to make my secant theta from here to become a subject equals to x minus 2. Okay? how do you know when you're going to start with this? So always look at that. If they have trigger, they have variable with unknown, try to play around with the identity. So the next one here, right, I'm going to make my tangent square theta equals to y minus 5. So I'm going to use these two to sub into my equation. So second square theta, that will be x minus 2 square, equals to 1 tangent square theta plus y minus 5. Since I'm going to express my y as a subject, so what we're going to do is y minus 4 equals to x minus 2 square. So my y equals to x minus 2 square plus 4. Hang on, let me finish. Yes. Okay, very good question. Please look back the formula sheets. Is your trigger identity. Alvin, do you get it? Alvin? It's from your formula sheets. Yes. Let me see whether I have any parts here to show you first. I don't have any parts here. Okay. Now, we look for the second one. They ask you to find dy dx in terms of x. So this one is simple. So basically you differentiate from your past one. There will be dy dx equals to 2 bracket x minus 2. So you see your x minus 2, you differentiate with x, right? It becomes 1, so you leave your answer in this way. Okay. We wait for Ipo. Okay, we move on to the next part. Okay, a curve has an equation found in part A. Alright, they said find the equation of tangent when the curve is theta equals to pi over 3. Now, come to this question because I'm going to use my dy dx to work on it. But in my dy dx consists of x. So a lot of people straight away sub in x with theta pi over 3, which is not correct. So come to this question, I need to work on my x. So from the statement they give you, my x is 2 plus secant theta. So basically you have to use a theta sub inside. So x equals to 2 plus secant bracket theta over 3. Okay, theta over 3, right, is actually equals secant theta over 3 is basically equals to reciprocal of 1 over cos pi over 3, correct? So my x is actually equals to 2 plus 1 over 1 half. So bring up your 2, basically your x equals to 4. Okay, same thing, I need to work on my y. For my y, right, I have, in the statement, I have phi plus tangent square theta. So same thing, I sub in phi plus tangent square pi over 3. So my y equals to phi plus sec 3 square. Sec and sec cancel. So my y actually equals to 8. So my first point for my equation of tangent, I get 4 and 8. Okay, next bit. I need to get my dy dx done. So in my dy dx, I have to sub in 4 into my dy dx. Okay, what do I get from my dy dx? Equals to 2 bracket 4 minus 2. So I get 4. Okay, so now I can form my equation of tangent. So what I'm going to do is, I'm going to take my two information, substitute 4a and dy dx equals to 4 into my y equals to mx plus c. So from here I get 8 equals to 4 multiplied with 4 plus c. So my c equals to 8 minus 16. C equals to negative 8. Therefore, my equations of tangent is y equals to 4x minus 8. Okay, do you have any question to ask so far? Any question? Okay, no, then today in the lesson we will stop here. Thank you. Bye bye.